So welcome students. We will continue with our discussion about the pin configuration of microprocessor 8085. We have discussed up to the lower byte of the address bus and the data bus, which is multiplexed from pin number 12 to pin number 19, and we have discussed about the pin number 20, which is available to connect the power supply 5 volt plus power supply to the microprocessor 8085. Now we will shift our attention to the next group of pins, that is from 21 to 28, which is termed as A8 to A15, and the direction which is important to note here, that the direction is shown in the outward side, number one, and the arrows are shown as the hollow arrows because they are part and parcel of a bus. Means they forms a group, and that group transfers either data or the address to a particular IC. Means it is a hardware connection, and all these pins, they are acting in a group. So the group from AD0 to AD7 plus A8 to A15, they forms the group of 16 pins, and these 16 pins are responsible to carry the address from microprocessor to the memory IC. In other words, microprocessor 8085 can access the desired memory location with the help of this address bus. Okay, and the pins from 21 to 28, they are unidirectional because address is always given from microprocessor to the outer world, and the pins from 21 to 28, they are basically used as the higher byte of the address bus. No data is included, no multiplexing is there. Therefore, the address is going in the outward direction only. Whereas the pins from 12 to 19, you will see that the arrows are bidirectional. Means the flow of the bits or the flow of the data or the address is towards the microprocessor. Means data can move towards the microprocessor, and the address is going outside the microprocessor. Also data also can move outside the microprocessor. Therefore, the pins from 19 to 12 from 12 to 19, they are shown as bidirectional, and pins from A8 to A15, they are shown as the unidirectional pins. Okay, so these pins carry the higher order of the address bus that is written here. I will just read it out. The address is sent from microprocessor to memory, definitely, and the 8 pins are switched to higher impedance state during hold and reset mode. That we will see in the due course. Okay, now we will shift our attention to the pin number 30, and that pin is of let me select the highlighter first, and let me select it. I have selected the highlighter, and we are discussing about this pin, ALE, pin number 30, ALE. ALE stands, it is an abbreviation or the short form of address latch enable. So it indicates whether the bus functions as address bus or the data bus. I will try to explain this in the detailed manner. Remember, microprocessor has two buses, the address bus and the data bus. Address bus is of 16 bits and the data bus is of 8 bit. Instead of allocating separate 8 pins for the data bus and separate 16 bits, which will comprise for 24 pins. So instead of wasting 24 pins for address and data bus separately, the designers have designed the microprocessor 8085 pin configuration in such a way that they have included address and data in 16 pins only, and the lower byte of the address is also used to communicate the data, to transfer the data. Means it is multiplexed. Multiplexed means it is used for both the purpose. It is used to give the lower byte of the address to the memory. It is also used to have or to give the 8 bit of data. So it is data for some time, it is address, a lower byte of the address for some time. Okay, but remember, data is also in the form of 0 and 1, and lower byte or higher byte of address is also in the form of 0 and 1. So when suppose a pattern is available from 12 to 19 of 0, 0, 1, 1, 1, 1, 0 and so on, that can be data, that can be lower byte of address. There is no specific demarcation between the data and address. So how microprocessor can understand that whatever pattern is available on the pins 12 to 19, whether microprocessor should treat that pattern as data or whether he should treat that pattern as lower byte of address. Who will tell microprocessor that this is data and not the lower byte of address, or this is lower byte of address and not the data? The particular pin ALE will generate the signal, and this ALE will tell that whether the signal is address or the data. So if ALE is equal to 1, means 1 is available at ALE by digit 1 or 5 volt, then bus functions as address bus. So whenever ALE is equal to 1, the available pattern from 12 to 19 will be treated as the address, lower byte of the address. And if ALE goes to 0, so this pin ALE goes to 0, then the bit or bits available, or the bit pattern available from 12 to 19 will be treated as data. So the ALE pin will tell the microprocessor whether to treat the bits available from 12 to 19 as lower byte of address or whether to treat it as a data. Either it will be 1, so it is a lower byte of address bus. When it is 0, it is the higher, it is the data available on the pins from 12 to 19. So this is the ALE pin, the function of the ALE pin. Now we will go to the next functions, next pin. I have discussed the pin number 30 ALE, but we left pin number 29 because pin number 29 is associated with pin number 33. So both the pins work together, and pin number S0 and S1, they are called as the status pin. So status is the word which is well known to the young generation. For you, it is not the foreign word because you keep on changing the status of WhatsApp only now and then. What for you change the status of the WhatsApp? You want to express what is going in your life, what is important thing which is going in your life, what you have performed, what you have experienced today, what is the important thing you have discussed today. So all these things, they are reflected in your status. Same thing, microprocessor 8085, I have told you that it cannot work separately. So number of integrated circuits, number of ICs, they are connected to the microprocessor 8085 and they are called as the peripheral ICs. But remember, all these ICs and microprocessor 8085, they work in synchronization. Their speeds are same, they share the data, they share their signals, they share their functions, means what is going inside a particular IC affects the functioning of other IC. What is going inside 8085 will decide what to do for the another IC, means the structural diagram of all these ICs, that diagram is in a coordination with one another. And for that purpose, it is very important for all peripheral ICs to know what microprocessor 8085 is doing at this time. And when microprocessor 8085 wants to communicate with all other ICs that I am doing this thing. See, you change your status when you go to a dam, and you want to express that I am at dam, I am enjoying. Similarly, microprocessor 8085 wants to communicate what he is doing to the other ICs, and for that he generates signals, and those signals are S0 and S1. They tell the current operation which is going inside the microprocessor 8085. There are the four operations which are microprocessor wants to communicate with the peripheral ICs. And number one, microprocessor, the operation is halt, means when a particular program is executed, and when the execution completes, microprocessor goes into halt state. No address is generated, no operation code is fetched, and so on. So operation is microprocessor is in the halt state, in the rest state. So he gives this notation and he sends this signal to the outer ICs by generating S0 is equal to 0 and S1 is equal to 1. So both the both these pins will have the 0 is equal to 0 and S1 is equal to 0. Then microprocessor is in the operation is halt state. When microprocessor is writing something, means microprocessor is giving the data or the result to the outside world, writing something in the outside memory or in the IO device. So it generates the signal S0 is equal to 0 and S1 is equal to 1. When S0 is equal to 0 and S1 is equal to 1, all the peripheral ICs understand that microprocessor is in the process of giving the data to the outer world, or it is writing the data. So it is busy. Its address bus is busy, its data bus is busy, and we should not disturb the microprocessor. So it will be understood by the peripheral ICs. Sometimes microprocessor wants to read the data, means the input devices want to communicate the data to the microprocessor for processing purpose. Microprocessor is reading the data. So microprocessor will tell other devices, other ICs, by generating the signal S0 is equal to 1 and S1 is equal to 0, 1 0 signal, and this will be communicated with the peripheral ICs, and those ICs will understand that microprocessor is in the process of reading the data and its address and data bus are engaged. Okay. And the last operation which microprocessor wants to communicate with the peripheral ICs is the opcode fetch. For this purpose, to understand what is opcode fetch, we have to understand what do you mean by opcode first. What is opcode? Opcode is the abbreviation or the short form of operation code. Microprocessor can perform a single task, a particular task, and we write those are the instructions which tells the microprocessor which task he is expected to perform. So these are called as the instruction. We generally write those instruction on paper in English like language, ADD, add, SUB, subtract, and so on. But microprocessor cannot understand English. So these instructions must be communicated with the microprocessor with in a digital form, and each and every instruction is of 8 bit instruction, 1 byte, 2 byte, 3 byte, but each byte contains 8 bit. So this 8 bit or 1 byte instruction, 4 bits in the beginning, they form a nibble, and last 4 bits they also forms a nibble, and we can convert those 4 bits into a hexadecimal number that we have discussed in the first semester. So the 8 bit, 4 bit, they are converted into 16-bit number. So each and every instruction is given a code of 16-bit or hexadecimal number. So each instruction, each operation is given a hexadecimal number, that is called as operation code, and that operation code is given to the microprocessor. How it is given to the microprocessor? Remember, microprocessor cannot read the opcodes from my paper. So microprocessor will read those operation codes in the forms and ones and zeros only, though I have stored those instructions in the form of hexadecimal number. But there is assembler which will convert those hexadecimal numbers into a particular binary pattern of 8-bit number. So I will have to store those operation codes. Suppose I have written 100 codes for a particular program. Microprocessor 8085 don't have its own memory to handle those 100 codes. Therefore, I will have to write those 100 codes into a consecutive memory locations. I will choose a particular memory location and I will start storing all the operation codes one by one. Once the operation codes are fed into the memory, I will ask the microprocessor to go to that particular memory location and to fetch. Fetch means to pull, to have the operation code. So microprocessor will go to the memory with the help of address bus, the 16-bit address bus. He will open that address location, or the memory location, address of that memory location, and he will fetch that operation code. That operation code will go into the microprocessor, and how it works, that we will see in detail. But remember that microprocessor needs to fetch the operation code from the memory location. So this, when the microprocessor is in this process of fetching the operation code from the memory location into its inside word, that particular operation is expressed or is communicated with other ICs by creating S0 is equal to 1 and S1 is equal to 1. When both these status signals are 1 1, all the peripheral ICs will understand that microprocessor is busy in fetching the operation code, and they will determine their functions accordingly. Okay, so S0 and S1, they are very important pins as far as expressing the status of the microprocessor and giving that status, communicating that status to the outer world. Then this is also an important pin, that is pin number 34, IO oblique M bar. So this is pin number 34, IO oblique M bar. Here IO stands for input output. Microprocessor is connected with number of input devices, and microprocessor is also connected with number of output devices. These input devices can communicate the data with SID. The output devices will receive the data or the result from the microprocessor through SOD, pin number 4 and pin number 5. If you are seeing here, pin number 4 and pin number 5. Remember, microprocessor is connected with input and output devices. Similarly, microprocessor is connected to the memory, and microprocessor can access 64,000 memory location. So each and every memory location is given an address, and microprocessor will identify that address, will go to that particular memory location, and will try to fetch the data, will store the data, whatever the function we expect the microprocessor to perform. Similarly, microprocessor is also connected to the number of input and output devices, and these input and output devices, they are also recognized by address, because microprocessor cannot go to the input and output devices physically. It will rush to the input output devices through address. So it will identify a input device A by a particular address, input device B by particular address, output device C by particular address. Means, to identify input output device, microprocessor uses address. To identify memory location, microprocessor uses address. Now, how microprocessor can understand that the input output operation is memory related or input output related? Means, whatever address is available on the address bus of the microprocessor 8085 needs to identify memory location or needs to identify IO device. Means, the address present is of memory location or it is of IO device. So this can be done with the help of this pin. Now, once this concept is clear, when the potential at point pin number 34 is 1, means 5 volt. So here we have not given bar, so this is the bar. When IO oblique M bar pin has voltage 1 or the binary number 1, then the operation is IO related, means whatever address is present on the address bus will be treated as the address of IO device. No memory is included. When IO oblique M bar is equal to 1, and when IO oblique M bar is equal to 0, definitely, because M bar stands for the operation, it is called as the active low operation. So whenever it is low, then it is M bar, so it stands for memory. So whenever IO oblique M bar is 0, it is memory related operation, and the address present on the address bus will be treated as the address of the memory location. Remember, whenever it is 1, the address will be treated as the address for the IO device, and when it is 0, the address will be treated as the address of the memory location. So this is the importance of IO oblique M bar pin. Okay, we came up to the RD bar, but let us stop here because we will have to discuss number of pins, and I will shift my attention. I will keep those pins for the next lecture, starting from RD bar, WR bar. These two pins we have left: RD bar, WR bar, then ready, reset in, then clock out, hold, HLDA, and VCC. So VCC we have discussed, but these 7 or 6 pins we will discuss in the next lecture. So I hope you are coping with me. Today intentionally I have I have used only English to express the concepts, because let us try different things. If you are comfortable with my English, because I have made my speed, uh, I have controlled my speed, I have lowered my gear, and I have used very simple English so as to give you a correct indication of whatever I want to express, I want to communicate with you. So let us hope that you have understood what the concepts of different pins. We will start our discussion from RD bar in the next video. So before turning it off, I'll of course write down thank you, and remember, I want all of you to come to this point, thank you point, because it is necessary for you to watch, to observe the complete video to understand the different concept. Okay, so let us stop here. Thanks for watching. Keep on watching, and please try to watch complete video. Try to communicate. Try to give the remarks, and try to give your responses in the response box. Thank you.